Welcome pre-cal students to class today on Thursday the 16th. Hope you guys are doing well. Hope you're ready to learn some math today. Go ahead and get your stuff ready to take notes, and let me make some announcements here while you're doing that. First of all, there will be a quiz on Saturday. I will email that quiz to you, so make sure that you're ready for that. I have toughened up on you guys, but it is for your good, so you're not working on old math while we're trying to cover new math. So your quiz is due Tuesday, and I would make it due Monday, but Sunday really doesn't count, so as a date to be working. So Tuesday is when your quiz is due, and it must be totally done, questions asked in my hand, or there will be points taken off. So please keep that in mind. Please stay on top of your integrity sheets. It's very important you do your homework every day. I would encourage you not to get behind. If you have any questions on your homework, contact me. I'm here to help you. Remember, when you come in when you walk through the door on the day of a test, no more videos can be watched for credit, so make sure everything is caught up, okay? Alright, that's basically it. It's almost the same announcements every day. Again, hope you guys are doing well. Contact me if you need any help, and let's go ahead and get started, okay? Grab your notebooks, pens, pencils, calculators, books, and let's get started. We're going to finish lesson 10.1 today, finally, okay? Now, we've spent a lot of time on that lesson, but I felt like it was a very important lesson. We will be looking at two topics today. Now, one of these topics is very similar to yesterday's material, and the other is not. Let's start today with a material that is similar to yesterday's material. Let me grab a drink here. Let's go ahead and start with the material that is similar to yesterday's material. Go ahead and copy this in your notes if you would, please. Again, don't forget my philosophy, please. I go fast, and you'll probably need to pause the video some, but I would rather do that than going too slow. So, writing sigma notation, the lesson is 10.1, and the date today is, as I mentioned earlier, the 16th, okay? Writing sigma notation or summation notation, lesson 10.1, and the date today is the 16th. Remember yesterday how we took problems like the one below and we solved it. Do you remember that? Yesterday we would start with 0. I think the I was right here. I forgot to put the I. There was an I here, I believe, and an I here. And we put these numbers in for I. Hopefully you remember that, okay? Well, today we're going to go backwards. I'm going to give you the list of terms that are being added, and you are going to write the sigma notation. Now, I try to fix right away when I see a spelling mistake, so I'm going to do that right now. And I do know how to spell going. I just hit the wrong key there. There we go. I'm going to give you the list of terms that are being added, and you're going to write the sigma notation, this expression right here. Now, yesterday I gave you this expression and you solved the problem. So today we're going to kind of go backwards, all right? By the way, before we look at our first problem, I want to say that all of this stuff we've been doing in lesson 10.1 is very important. It is getting you very familiar with series and sequences. And that's something you're going to use throughout chapter 10, guys, okay? And that is why I've really taken my time with this first lesson in chapter 10. All right, let's continue on. Let's go ahead and copy this first problem down. I want us to take these numbers and write them in sigma notation. Now, let's think this through for a second. I'm going to kind of be funny with you here for a second, but we can obviously do this, right? This is a safe thing to do. We can always draw our sigma symbol first. So there we go. That's a safe thing to do. And by the way, I'm not sure if you're going to use I or K or X. You can use whatever you want, okay? I'm going to use K just because I feel like it. So I'm going to put a K here, all right? Now what we're trying to do is we're trying to find that expression almost like an nth term. And that's why this is like yesterday's material, almost like an nth term that we're going to put here. And you say, Mr. Earhart, why is that like an nth term that we learned to write yesterday? Well, think about it. We know we're going to put a 1 in first, right? That's for the first term. And then we're going to put a 2 in. and then we're going to put a 3 in, and then we're going to put a 4 in, and then we're going to put a 5 in, etc. So we know we're going to start with a 1, and we know we're going to put a 2, a 3, and a 4, and a 5 in. So it really is like finding an nth term, and we did this yesterday. So let's see if we can't find a pattern. I wrote the term numbers up top. I have 7 right here, and then 14. I'm adding 7 over and over, so I really could say 7 times 1. 14 would be 7 times 2. 21 would be 7 times 3. 28 would be 7 times 4. And 35 would be 7 times 5. So I notice all of these have 7. Okay, so I can put a 7 put a 7 down here. And then notice I have a 1 here, and a 1 here, 2 here, and a 2 here, 3 here, and a 3 here, 4 here, and a 4 here, 5 here, and a 5 here. So the actual term number matches the number we're putting in. So I would put an N right here. Now let's see if that works. If I put a 1 in for N, I would get a 7 out. That's good. If I put a 2 in for N, I'd get out a 14. If I put a 3 in, I would get out a 21. If I put a 4 in, I'd get a 28, a 5, a 35. Good. So here's what you do. We're almost done. What I've written here is the first term is K. The first term is what I'm going to put in for N, so I put a 1 here. Notice how there's a dot, 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 dot. That means this series, this sum continues on and on. Now normally you'd put a 5 here because there's 5 terms, and that means you're going to find the sum going from 1 to 5. But please listen to me, students. Because there's dots going on and on and on, that means we're going to put the infinity symbol, and the infinity symbol looks like this. If there weren't dots there, then we would definitely put a 5 right there and be done with it. But because there's dots showing that the sum continues on and on forever, then we say, okay, we start with number 1 and we go to infinity. And that's it. Students, it's not that hard. We're finishing up lesson 10.1. The material today is really not that difficult, okay? We're taking sums and we're writing them in sigma notation. It's just the opposite of what we did yesterday, all right? Okay, let's go ahead and let's try another one. Let's practice some more. Now, I'm going to write this in sigma notation. Notice I'm adding all of these numbers together. Now, let's take our time here and let's think about this, okay? Here we go. First of all, I'm going to write the term numbers up top like I taught you to do yesterday. Term number 1, term number 2, term number 3, term number 4, and term number 5. By the way, it will not always be 5 terms. That's just a coincidence that I had 5 terms here and 5 terms here. Now next we're going to look for a pattern. Now I see some perfect squares here in the denominator of 4 and 9 and 16 and 25. I'm going to put a 1, and I'm going to put 1 over 2 squared. For 1/9, 1 over 3 squared. For 1/16, 1 over 4 squared. For 1/25, 1 over 5 squared. Now, I've got a pretty good pattern going on. Notice I have 1s all the way across the top and the bottom. I'm not sure what I did right here. That's really weird. Well, Mr. Earhart's getting old, I guess. Let's clear that out of there and get rid of it. Okay, now 16 would be 4 squared. Oh, that was weird. Sorry about that. But anyways, and then the bottom here, I have a 2, 3, 4, 5, and I have all 2's for powers. The only one that's messing me up is this 1 right here. Now, if I could somehow make this 1 look like a fraction, well, hold on, I can do that. 1 is the same thing as 1 over 1, right? Isn't 1 over 1 still 1? And if I square the 1, that's okay, because 1 times 1 is 1, and 1 over 1 is 1, excuse me. So everything's good. So it looks like I've got a pretty good pattern going on here. And I'm going to have to go back one step. Would you please forgive me for making a mistake back here? I'm sorry. It's not that big of a deal. I'm so sorry, guys. But look, see how there's a K right here? There should be a K here sitting there, not an N. Now, I can do one of two things. I can make this K become an N, or I can make this N become a K. It really doesn't matter, but I apologize for that. Okay, it's my fault. There we go. Okay, so let's go ahead and finish this problem now. So I'm going to write like an nth term. I guess we'll call it a k term since we're using k on these. You can use whatever variable you want. If you want to use n, that's fine. But I'm looking here. First of all, I notice all of these have a 1 up top, so I'm going to put a 1 up top. Then I notice all the powers are 2, 2, 2, 2, 2, 2. So I'm going to put a little power here for 2. Then I notice that term number 1 has a 1 here, term number 2 has a 2 here, term number 3 has a 3 here, term number 4 has a 4 here, term number 5 has a 5 here. So I can just put n, or I'm sorry, we're using k, my fault. Old habits die hard. I can put a k here, k squared. Does that work? Well, let's see. Put a 1 in for k. 1 times 1 is 1. 1 over 1 is 1. Now put a 2 in for k. 2 times 2 is 4. 1 over 4 is 1/4. Now put a 3 in for k. 3 times 3 is 9. 1 over 9 is 1/9. Now put a 4 in, you'll get 1/16. Put a 5 in, and you'll get 1/25. So this definitely works. So this is my term that I'm now going to put with my sigma notation. There we go. And now k starts at what term? Term number 1. And we're adding all the way to the 5th term. Notice there's no dots. If there were dots, then I would put infinity right here instead of the 5. All right, but there are no dots, and so I'm going to put 1 and 5. And if you were to work this problem out, you would get this list of numbers. You would say, okay, let's put a 1 in for k, and you would have 1 over 1 squared plus, put a 2 in for k, 1 over 2 squared, put a 3 in for k, 1 over 3 squared, etc., etc., and you would get this exact sum out, and then you could add them up. Okay, so there we go. We're only doing 2 of these. I'm trying to keep the video shorter today because I want you to focus on your homework more than anything else. And I've thrown some pretty good curveballs at you guys, so you better be ready for that. You better do the homework with an open mind, and you better be ready to watch the video and get some help. So that'll definitely be a challenge for you. Okay, well, that's I told you we're looking at 2 topics, so we have one more topic to look at. Please copy this in your notes. We're going to look at a title called Recursively Defined Sequences. Lesson 10.1. The bark is definitely worse than the bite. They're not that hard. It sounds bad, but they're not that hard. And of course, today is still the 16th. Go ahead and copy this in your notes, please. And let's take a look at recursively defined sequences. Now you're probably saying to yourself, what is a recursively defined sequence? Which would be a great question since we're going to look at these. So copy this down. A recursively defined sequence is, now this is going to sound like Greek to you, but I'll explain this later. It's a sequence in which terms are defined by their previous terms based on a recursive formula. So it's a situation where maybe I give you the first term, and then I give you a formula that allows you to take the previous term and plug it into the formula and get out the next term. That sounds like truckloads of fun, doesn't it? Of course, I'm joking, but it's really not that hard. I think you'll enjoy these. They're pretty simple. They're easy to do, and I think you'll like doing them. So, but that is what a recursively defined sequence is. Okay, a sequence in which terms are defined by their previous terms based on a recursive formula. Okay, so with that in mind, let's go ahead and try our first problem. I'm looking at my slides over here. I think we're going to do 2 problems and then give your homework to you and let you get started. So it's been a pretty short video. So now the homework, of course, will take you some more time, but I've kept the video a little short today. So here we go. Okay, now what we're going to do for this recursively defined sequence is we're going to find the first 5 terms. So I probably should have typed that in, but I did not. So go ahead and write that in. Find the first 5 terms. Okay, find the first 5 terms. Now we already have term number 1. It's 5. Okay, now this is your formula right here that's going to help you find the other terms. Now please watch carefully how I do this. Okay, I have term number 1. It's a 5. This formula here is what we call your recursive formula, and this recursive formula will help you find term numbers 2, 3, 4, and 5. So watch this. I'm looking for term number what? 2. So I'm going to use this formula right here. Now if I'm looking for term 2, notice the formula says n plus 1. Well, if I'm looking for term 2, then obviously I'm going to put 1 plus 1. Do you see that okay? Because I want it to equal to 2. I'm looking for term 2, correct? I have term 1, it's 5. I'm looking for term 2. So I must put a 1 here because I want this to be a 2 right here. Because I'm looking for term 2. 1 plus 1 equals 2. Now stop right here. A n. Now what did I put in for n over here? Do you remember what I put in for n? I put a 1 in, correct? So that means for this problem right here, for this part of the problem, n is 1. So next, I'm going to put a subscript 1 minus 3. Now hold it. I know what a subscript 1 is. It's 5. So what I do is where a subscript 1 is, I substitute a 5. And so term 2 would be 7. There we go. 2 times 5 is 10 minus 3 is 7. So all that I did is I took the previous term. I'm looking for term what? 2. And I picked up term number 1 and I put it into the formula. And that gives me out term 2. Let's find term 3. Ready? Watch this. Let's find term 3. All right, I'm looking for term 3. And here's my formula up here. All right, see my formula up here? This is not my formula right here. This is my formula up here. It's n plus 1. Now I want this whole thing to be a 3, so I better put 2 plus 1. So I'm going to put a 2 plus 1. That gives me a 3. Equals, now look at your formula, it's 2 and then a subscript n. Now what did you put for n? See your n right here? What did you put for n? You put a 2 in for n. So we got to put a 2 in for n. So it's a subscript 2 minus 3. Well, I know what the second term is. Remember I found that earlier. I easily know what the second term is. That's a piece of cake. The second term is right here, 7. So I'm going to put a 7 in. 2 times 7 is 14 minus 3 is 11. So if you're starting to see what's going on here, a pattern, in other words, you're seeing that in order to find term 2, you put term 1 in, and in order to find term 3, you put term 2 in. You can take a shortcut, I don't mind that. In order to find term 4, we're going to take term 3 and put it right here. So it'd be 2 times 11 minus 3, and that would be 22 minus 3, which is 19. All right, let's find term 5. In order to find term 5, we're going to put term 4 into the formula. So 2 parentheses 19 minus 3, that's 38 minus 3, which is 35. And there we go. We did it. So you just found the first 5 terms of a recursively defined sequence, and you did that based on what we call a recursive formula. It's not that hard. Let's try one more, and then you can start your homework. Okay, here we go. Let's take a look at this problem here. First of all, let's find the first 5 terms. I should have typed that in, but I didn't. Let's find the first 5 terms. So we have a subscript 1. So we're going to find a subscript 2. So I'm going to use my formula here. Here's my recursive formula right here. And so I'm looking for term 2, and I have n plus 1. So I better put 1 plus 1. That gives me a 2 equals the square root of. Now, what did you put in for n? You put a 1 in for n. So a subscript n, or a subscript 1, would be right here. Well, hold on. I know what a subscript 1 is. It's 256. So I'm going to get rid of this right here, and I'm going to put 256 right here. Now, continuing on, the square root of 256 is 16. So I found term 2. So I think you can kind of see now the pattern. In order to find term 2, I had to substitute term 1 in. So in order to find term 3, I'm going to substitute term 2 in for this. So the third term would be the square root of 16, which is 4. And now in order to find term 4, I'm going to put term 3 in. Term 3 is 4, so I'm going to put a 4 right here. So the square root of 4, which is 2. And then in order to find term 5, I'm going to put term 4 in. I go back to the previous term and put a 2 in for a subscript n, and that would be the square root of 2. And there we go. I hope this is making sense. You might have to rewind the video and watch it a couple times, but that is how you do these. They're not too difficult. And your homework, which I would really work on and watch the video because I've thrown some curveballs at you. Your homework is right here, page 851, 51 through 65. Not too hard. That's what, 8 total problems, so pretty reasonable. 8 problems I want you to work on, and that is it for today. Call or email if you have any questions, and I hope you guys have a good day today.